Okay, question number 2, data analysis part. Okay, an experiment is conducted to measure the specific heat capacity of water. A mass of water is placed in a glass beaker and energy is transferred from an electric heater. Okay, so you have a beaker and you see this beaker is seen to be open. Okay, there is no lid over here. And there is some water, there is a heater here. The data collected are the mass of the water. This is M, this is delta M. Change in temperature, this is let me say dt. I'll write dt here for some reason, and this is your, okay, I'll write t. I'll t here, and this will be delta t, and the energy transferred from the electric heater, this is energy, and this is delta E. Okay, and note that this has two significant figures, okay. All these actual values are having two significant figures, and if you look at the uncertainty here, absolute uncertainty is 1, 1, 1 here. Okay, so therefore your final answer should also be two significant figures plus or minus one significant figure. If they ask you to find out something from here, what can they ask? They can ask you to find out the specific heat capacity. It's been asked. Okay, so this is how your answer should be. Okay, now let us start with this. Calculate the specific heat capacity of water. Simple question. So what you know is that we can now write E is equal to mc delta T, right? So now E, what is E here? E is 16,000 is equal to mass. Mass is 0.25 multiplied by C multiplied by change in temperature is 14. I will not put this value here. Okay, that's the reason I put delta T. I'll put dt here for some reason. Okay, so therefore this change in temperature here is seen to be 14. So calculate the value of C. C value should be equal to 16,000 divided by 0.25 multiplied by 14, which should be, now let us calculate this. It will be 16,000 divided by 0.25 is equal to so much, divided by 14 will be equal to 4,571. 4,571 joules per kg Kelvin. But as I told you, this value should be only two significant figures. See, here it is four significant figures. So what I will do? I'll truncate it by putting a tilde here. Okay, which means approximately this should be equal to, how do I truncate this one? I will not put this as 4500. I will put it as 4600 joules per kg. This is what you see in the marking scheme also. Okay, now next, determine the absolute uncertainty in the specific heat capacity of water. Absolute uncertainty you need to find out. Now you see, so we have got E equal to mc delta T. So what you do is take C as a subject. Don't directly apply the uncertainty analysis here. Take C as a subject, and let me call this delta T to be some Ex over here. Okay, delta T to be X. In other words, I can now write this as mcx. Okay, for some reason I'm going to write like this. So not to get a confused over here. So therefore I want value of C. C should be equal to E by mx. This is the first step one need to do. Do not take directly delta E by E. Okay, so therefore now next what we do? We will find out delta C by C is equal to delta E by E plus delta M by M plus delta X by X. Okay, and next what do I do? Now I will calculate this value. Now what is delta E by E? Let us go back here. Delta E is 300. Delta E is capital E is 16,000. So I will write down this as 300 divided by 16,000 plus delta M. What is delta M? Delta M is 0.002 and this is 0.25. 0.002 divided by 0.25 plus delta X. What is the X here? X is temperature. This is the one. So delta X here is 0.5 divided by 14. So now I will write this as 0.5 divided by 14. Now let us calculate all these values. I have this 0, 00 and this 00 goes away. So I have 3 divided by 160. Oh, I made mistake. 3 divided by 160 is equal to 0.01875. I'll write it here. 0.01875 plus 0.002 divided by 0.25, 0.008 plus 0.5 by 14. 0.5 divided by 14 is 0.0357. 0.0357. Now I will add all of them, so which will give me 0.01875 plus 0.08 plus 0.0357. I get the answer 0.13445. 0.13445. I make it as 0.1345. Okay, now I've got this value as delta C by C equal to so much. So delta C should be equal to 0.1345 multiplied by C, which should be 0.1345 multiplied by, don't take the truncated value here, approximate, take the actual value here, 4571, 4571, 4571, which should now be equal to multiplied by this, multiplied by 0.1345 multiplied by 4571 will give me 614.79, which is nearly 615. It is even 615, and 615. Just a moment. We made a mistake. I think we made a mistake somewhere over here. Let me check it out once again. So I should not be getting this much. It will be much more lesser. Just give me a moment. 0.5 divided by 14. 0.5 divided by 14. 0.0357. Okay, I think I made a mistake here. 0.0357 plus 0.008 plus 0.01875 will be 0.06245. Okay, I made a mistake here. This is incorrect. This should be 0.06245. 624. Okay, so the whole thing goes away. Because I have written this in my paper, so I just cross verified it. So I get delta C is equal to 0.06245 C, which should now be equal to 0.06245 multiplied the value of C is 4571, which should now give me multiplied by 4571 should give me 285. Yeah, this is the right 285. It's 285. What is the decimal here? 285.45. 285.5. Okay, I get this value. So what is this delta C? Delta C is joules per kg Kelvin. So finally, okay, so we got this value. Next, so let us see. Determine the absolute and specific heat capacity of water. We have got this. Okay. Write down the specific heat capacity of water and its absolute uncertainty to the appropriate number of significant figures. Okay, so therefore I need to get the value of C. So appropriate number of significant figures. So what I said already, that they should have two significant figures here plus or minus 1 SF. Okay, I already told you here. Uncertainty should be one significant and there should be two significant figures. So therefore, what's the value of C? C is two significant figures is 4600. So I'll write this as 4600 plus or minus. Now the uncertainty I got is 285, but I need to convert it into one significant, which means how much is it? This is nearly 300, right? So therefore I will write this as plus or minus 300 joules per kg Kelvin. So I'll write it like this. This is the right answer. Okay, according to the scheme also. Right. Let us look at the next question. Outline one source of systematic error in the experiment and its effect on the calculated value of the specific heat capacity of water. Now, do we have a systematic error and what is the result for it? Reason for it. Now, you know, the specific heat of water is always around 4200 joules per kg Kelvin as seen in the tables, okay, in your data book later. But what is the answer I am getting? I am getting 4600. I am getting 4600. 4600, which means what? Something is wrong. Okay, I have got a very higher value over here. Okay, so what is wrong here? What went wrong? Why did I get a higher value? Okay, so now see, and its effect already we have got this. We have compared it with it and we have got it. So somewhere we have to reason looking at the variables. Okay, there's a clue that is being given. Okay, if you know the actual values, okay, you get a clue saying that the specific heat of water is larger. So why did it happen? What was the reason? Okay, that's what is the question. Okay, now we need to look at, okay, so what went wrong over here? So towards it, now we know how do we calculate the specific heat? Specific heat is given by E divided by M delta T. M delta T, right? Okay, E equal to MC delta T, I should get like this. So when will C get larger? See, C experimental here is larger. So why do we get larger? maybe E should be larger. The amount of energy that you supplied was larger and you estimated it to be smaller. That's one reason. The second reason could be maybe mass. Okay, you have calculated something, but the actual mass was really lesser. Okay, actual mass was lesser. Actual mass is lower, but the experimental mass that you have considered is higher. You would have considered 300 grams, but actually there is only 280 grams. It's a possibility. And maybe delta T, the change in temperature that you consider, is also much lower actually, but you have considered to be much higher. This could be the two reasons. Now let us look at what is the experiment you are doing. You are doing an experiment like this. You put the water inside a beaker over here and you started heating here. And the lid was open like this, right? That is what the diagram is given. Otherwise, you would have just directly given the question. Now, if this is the case, now as you heat it for a given temperature, what will happen? Some amount of water would have got evaporated. So the water that you got over here is much lesser. In reality, it is much lesser. Okay, but what is happening over here? You are considering the full volume of water, or the mass of actual water that you have considered is larger. You would have considered 300 grams of water, but the actual mass of water could be only 280 grams because part of the water is already evaporated because you started heating. That was not considered. So throughout the experiment, how many ever trials you are doing, okay, that was not considered. As a result of this, there is a possibility that this M is always lower. This would have an effect on C. And what is the effect on C? The C would have been higher, right? And that's what is in C, right? C has been higher over here. So that could be one of the reasons. And secondly, okay, energy. Now when you take up the energy over here, energy is seen to be transferred. See, whatever energy you have given over here, it not only went in increasing the temperature, okay, but part of the energy made in evaporation and some energy has been lost over here. Okay, energy has been lost by two methods. The first was it heated the container. Did we ever consider that? We never considered that, right? Heated the container is the first one. Then secondly, energy is lost. So that also we did not look into it. Energy is lost to the environment because it was open. So as a result of it, energy is lost over here also. So and hence the energy that we calculated was much lesser, but the energy actually supplied was much higher. Okay, that we did not look into it, and this could also be a systematic error. Okay, so therefore, if you want to conduct this experiment, you need to close the lid and do it, and every time you need to monitor what is the mass of the water. Okay, so with this, I think we have come to an end to both the questions, and I hope this session was useful. Before you leave, do like, share, and subscribe to my channel for more updates. Then, of course, we'll be bringing more number of updates for this. And tomorrow's video would be on projectile motion. I already given the worksheets. Tomorrow morning in the WhatsApp group, you will be at 8 a.m. You will be getting the worksheets on the projectile motion. Okay. Thank you.